Hello, Assalamualaikum. My name is Sarah binti Muhammad Sidin and my matrix number is CF170077, and today I'm going to present about our group project Steel and Timber Structure Design. In my presentation, I will discuss with you about our frame geometry, our structure layout, sketch of the load distribution, and lastly about selection of applied load in our project. Truss is arrangement of bars connected at joint by bolting or welding. It is used to give strength and support to the roof. There are many types of trusses. The type of truss that we are used in our project is house roof truss with dimension of 20,000 times 18,000 millimeter. The total height of the truss is 3 meter and overall span is 21 meter with 16 degrees of slope. The height of the column for this building is 4 meter. In this slide, you will see our structure layout of the building. For ground floor, we are using concrete with 250 times 450 beam. However, for the ceiling, we are using steel using universal beam 254 times 146 times 37. This slide shows the top view of the building with the dimension of the roof and the slope. The arrow shows the slope of the roof. This drawing shows the load distribution of the building. As you can see, the arrow is from the top, which is the roof, transfer to the roof beam, and then go to the column and transfer it to the foundation. According to the Eurocode 1 and Step Preliminary section, the parameter need to be considered to design this project is by using Malaysia National Annex with FU. Ultimate tensile steel strength of steel is 407,800 km per meter square with maximum allowable local deflection is 250 mm using steel grade 275. Using roll section, and yield strength is 253,200 kN per meter square. This slide shows the calculation of the load distribution for our project. So for self weight, we will calculate by formula 1/100 times 5.37 plus 0.053 times area. So calculate the area, which is 20 meter times 18 meter, and then put it to the area, and the result is 0.2445 kN per meter square. For top chord, our permanent action is from metal deck plus insulation, and the total is 0.55 kN per meter square. QK is variable. For QK is ceiling and finishes, which is 1.0, and WK is 0.75, which is the wind load. For bottom chord, the GK is same with top chord, and our spacing between truss is 5 meter. For bottom chord, the GK is same with top chord, which is 0.55 kN per meter square, and the spacing, as I said before, the spacing between truss is 5 meter. So the GK times with 5, QK times with 5, and WK also times with 5. So from beam RB1, RB2, RB3, and RB4, top load transfer is for GK is 5.5 times half of 18 meter, which the total is 49.5 kN. For the QK is 5.0 kN times kN per meter times half of 80 meter, which is 45 kN, and WK is 3.75 kN per meter times half of 80 meter, which is 33.75 kN. For roof beam 1, 2, 3, and 4 carrying GK 9.9 kN per meter, QK 9 kN per meter, and wind load is 6.75 kN per meter. And for roof beam 5 and 8, the load transfer is 5.5 kN per meter times 5 meter, get 27.5 kN, and for QK 5 kN per meter times 5 meter and get 25 kN. For wind load, 3.75 kN per meter times 5 meter total of 18.75 kilonewton. The coverage of truss for spacing 5 meter, roof beam 5 and 8 carry, GK 5.5 km per meter, QK 5 km per meter, and WK is 3.75 km per meter. For roof beam 6, 7, subjected to the load transfer, but depending on the truss arrangement, the load transfer is GK is 5.5 km per meter, QK is 5 km per meter, and WK is 3.75 km per meter.
Assalamualaikum, and my name is Muhammad Azhar bin Umar, and I would like to present about truss. As for the truss design procedure, first we start with type of truss, which is we choose our bottom chord truss. Then we determine the dimension of truss and apply load. Then we design the purlin and determine the external force. And after that, we calculate the maximum inner force for every truss member. After that, we group the truss member according to tension and compression member. For the tension member, which is bottom chord and vertical member, we estimate the critical size. From the critical size, we select the section by using table of section and properties. Then we check the tension and TRD, which is plastic resistance and ultimate resistance. From there, we take the lowest resistance and make sure the resistance is greater than NED. For the compression member, which is top chord and slope member, we estimate the critical size areas. Then we select the section from the critical size, determine the yield strength table 3.1 and classification section class table 5.2. Then we checking by determine the maximum compression resistance in class 6.2.4 in Eurocode 3. Then we check the determine the buckling resistance in class 6.3.1 and make sure both of the resistance are greater than NAD. If the both sections are okay, we adopt the size then end. As the purlin design, we follow BS5950 clause 4.12.3. Then from our appendix D, the purlin use single angle 80x80x10L. For the truss geometry loaded analysis, they are table we conclude from our analysis. Top chord has the force member 190 kN. Bottom chord has the highest member 183 kN. Vertical member has the higher member 45 kN. Slope member has the force member 34 kN. Then this force we are using in our design. This is our calculation design that you can refer in appendix E. To summary the design truss member, we use T grade 2705, and as you can read, this is our member size for each member: top chord, bottom chord, vertical member, and slope member. As for design of connection between member, we use a welded connection, which is the cover plate is 110-20 mm thick type in grade S275 and 8 mm welded are used. The welded connection design checking as in appendix J1. The welded connection detailing as in appendix K.
Assalamualaikum, and thank you for Dr. Hilton for teaching me around one semester to complete this project. My name Tuan Muhammad Alif Azlan bin Tuan Mustafa. I would like to explain about the beam. Beam is know that it's designed to provide the sufficient resistance to bending moment. Actually, the structure should be checked for the following at critical. For the first, combination of bending and shear force, deflection, lateral restraint, local buckling, and web bearing. For this project, our group used a beam with a side universal beam 254 x 146 x 37 grade 275 for use for a steel structure. Okay, for the ground floor, we use the beam size 250 and 450 for ground beam concrete. This is a procedure with start and calculate the VED and MED, and then we need to select the section, determine the yield strength according to the table 3.2, and then if the design okay, we proceed to the shear buckling, and its design in the system leveling is okay, and we proceed to determine the combination of element resistance required. and then we check the deflection. This is a ground beam for using for this concrete, as we know that the size is 250 and time 450. This is a roof plan steel structure. This is a calculation for make an analysis of a roof beam. Okay, for the first we need to know the loading on a roof beam and need to calculate the GK and QK, and then we check a MED, a VED and a MED, and then we continue with loading a roof beam and for calculate the safe weight, dead load from roof and live load and design. Actually we use a 1.35 GK plus 1.5 QK, and we got the value 11.5 kilonewton per meter. And then VED and MED respectively we calculate 34.5 kilonewton and 51.75 kilonewton meters. And then we continue to estimate the size of beam, WPL critical, and then we try use 254 times 140 and times 37. Okay, for the grid strength FY, we need to refer the table 3.1 and determine the grade yield strength S275 and determine the section classification. Therefore, the section is classification is under class 1 under rubber banding. This shear resistance VED over VED is small or equal to 1.0, and we need to check a shear buckling according to class 6.2.6, and then the shear buckling resistance equal that wool web. Therefore, for the shear buckling resistance of the web does not need to be verified. This is shear resistance for bending and combination bending and shear resistance according to class 6.2.3. And then we need to check a deflection. For deflection under a factorial impact imposed load, we got the value as actual is lower than as limit deflection of limit. Okay, is consider is okay.
This part discussed on the column. What is column? Column is a member subjected to compression are typically referred to as their columns or strut when they are orientated vertically. Columns are vertical member used to carry axial compression load, and due to their slenderness, it is prone to buckling. Simple construction, members that connected by normally pin joint and the horizontal force are restricted by bracing. Beams that connected to the column face usually inducing a small bending moment due to eccentric application of the transfer force. Beams are connected to column by means of a simple construction. So here in the calculation we used a simple construction method, which is we have two beams that connected to the column face, which is beam A and beam B. Beam A, the load is 34.5 kilonewton and the beam B is 56 kilonewton, and also we have load from the truss, which is 59.7 kilonewton, and the length of the column is 4 meter, which is bring out ultimate load due to self weight is 5 kilonewton, which is the self weight of the column. And the nominal length, we have few cases, but here we have assumed that the both end are one of the end is fixed and one of the end is pin. So due to this case, the LE is we use 0.85 L. The design procedure of column, it start with estimate support condition of the steel column, which is in this project one end is fixed, another end is pin. Estimate all the subject load onto the column, which is in this project we have beam A, beam B and truss, the load from the truss. Determine the maximum design compression force, NED. Choose the grade and cross-section size that's suitable for the design. And the next step is classify the cross-section of the steel column. We have class 1, class 2 and class 3. Determine the slenderness of the column. And the next is determine the maximum compression resistance, and then check buckling resistance, and the last one is lateral torsional buckling resistance. And the end of the calculation, we have to get the value less than 1.0, which means the provided size is suitable. First of all, the column length is 4 meter, and the load from the beam A, beam B and the load from truss is already mentioned, and the ultimate axial load NED, which is total of the all load including self-weight of the column, which is 155 kilonewton total of the load. And the proposed size for this column is 152 times 152 times 30 universal column, and the steel grade used for this part is S275 due to the thickness of the column is less than 40 meter, so we chosen from the table. So the grade of the grade is 275. The section classification overall is in a class 1, and the compression resistance is 103 kilonewton, which is more than NED, which is okay. Buckling resistance, which is 558 kilonewton, more than NED, okay. Lateral torsional buckling resistance, which is 56.1 kilonewton meter, and the bending resistance is 30.80 kilonewton meter. And the last checking for the column is we get 0.75, which is less than 1, means okay. So the overall calculation conclude that the proposed size is acceptable for the column.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Shazibati Kamrul Zaman, CF1700393. Now, I will talk about connection. Introduction. Steel structures are built by a proper connection of the standard section available. The links are essential part of the steel framework and construct more conventionally than a single component. The connection are generally provided in the following case. When they are requirement, the cutter are heavy load and long span, then the build-up section are to be provided. In case of long span, the length of the standard section need to be connected with other section. The different member to be connected at the end. For example, secondary beam to connect to the primary beam, column and footing. There are two classification of connection provided in the steel as follow. One is a welded connection and two is bolt connection. So, bolt connection. Bolting is a common infill connection as it is easy and cost effective to make. Bolting is often considered from safety and to be more common in field connection. There are two types of bolt. First one is a black hexagon. It is known as a black bolt, made in a mild steel and are typically grade 4.6. Fitting the whole diameter is around 1.5 to 2 mm large than diameter of the bolt. Where the bolts are tightened, snugly fit, high strength black bolt grade 8.8 can be also used. High strength friction grade HSFG perform well under condition of flat tilting or fatigue load. Tension in the bolt ensure that no slip. 8.8 to 10.9 grade and tempered alloy steel. This is a procedure to design a bolt connection. Firstly, we need to check the minimum and maximum spacing and each distance. We need to refer to the table 3.3. After that, we check the nominal clearance for bolt and pin. Then, check the diameter of bolt and decide the nominal value of heel strength and the ultimate tensile strength. This one you can refer to the table 3.1. After that, calculate the shear resistance of the plane. Then, calculate the bearing resistance on the plate or section through which bolt pass. So, we need to check the verification of the design of the bolt. Now, we go to the design of connection bolt. Beam to column connection. Okay. Here for the beam to column, Checking on column section, I'm using 18 mm diameter with grade 4.6, and the verification to all these bolt is okay. Next, we go to the beam bolt. For the beam bolt, I'm using 16 mm diameter and grade 4.6, and all the verification is okay. Next, we go to the truss to column connection. For truss to column connection, the diameter is 18 mm, grade 4.6, and the verification for all this is okay. Next, we go to the truss. For the truss, I'm using 14 mm diameter, grade 4.6, and the verification is okay. Now for detailing of connection. Here is the detailing of the connection. That's all for me. Thank you.
My name is Muhammad Alif Azlan. I will explain about the StepPro software that were used to complete this project. StepPro is a structure analysis and design software which is widely used to analyze and design structure for bridge, tower, building, transportation, industrial and utility structure. Actually, during designing the structure steel for canteen school, and the steel software was used to determine the axial force for the truss, column, beam and connection. This software was very useful designing and completing our project. Okay, these are size that were used in a StepPro. Okay, this is a ground beam and the dimension of the school canteen. This is a wool structure in the StepPro software. This is a wool structure after applying the type of material and section classification. This element is represent the every element in the structure. This report summary of reaction. This is bending moment for the truss. This is last output that we got, which is 0 error and 5 warning. It means that this design is safe to use. Thank you from our group.